when you have any given function at all, let's say this function, and you want to find its maximum height. And this is, I'm going to use a function that's kind of like this one. It's going to be slightly different though. Here's what I'm going to do. I'm going to take a pen, and I'm going to throw it up in the air, and it's going to follow a parabola, isn't it? And if I throw it upward, like this, at 10 feet per second, it's going to follow a curve based on following. F of x is equal to, this is the curve it's going to follow. Gravity is going to affect it at 16 feet per second downward per feet per second, x squared. I threw it upward at 10 feet per second, so it's plus 10x. And it started about 4 feet off the ground, so I have my starting area, which is 4. Got it? So I throw it up in the air, and it follows a nice parabola. If I graph this thing, it looks like a parabola. It looks like this. What happens at x equals 0? At time 0. This is time, this is position or height. It starts out at 4 feet. 1, 2, 3, 4. Then it goes up a little bit and falls back down fairly quickly. 1001, 1002, 1003. Somewhere between 2 and 3 seconds, or somewhere around 2 seconds, it hits the ground. So, I actually gave it some velocity in that direction so you guys can see it modeled. Normally, I'm talking about just throwing it straight up in the air. You understand what I mean? It doesn't affect it whether I'm moving or if I do it straight up and down. It just makes it easier to kind of visualize it when I do it that way, okay? So here's what's going to happen. It's going to go up for a little while, and then gravity's going to take over, and it's going to come back down, isn't it? Yeah. I am interested in, possibly, the maximum height. That might be something I'm interested in. I want you to notice something. Look at your tangent line to my curve. In other words, my instantaneous velocity. Look what happens as I get higher and higher. What's happening to my tangent line? The tangent line is getting less and less and less. What happens at the very top? It's 0. In other words, when I throw an object up into the air, it goes up in the air and stops instantaneously and then falls back down again. Now I know in the cartoons they let it hang for a while, but it's actually instantaneous when it stops moving and then accelerates downward, doesn't it? At its highest point, at its very highest point, doesn't it stop entirely and have a velocity of 0?
Yes.
Its instantaneous velocity at the very top is exactly equal to 0. Its velocity at any given point is equal to the derivative. Is that clear? Yep. If I take the derivative of this function, it tells me what the velocity is at any given point on this curve. So I'm going to take the derivative of this. I know it's really difficult, but we're going to try it. F prime of x. I am going to take what? I'm going to take my exponent and I'm going to multiply it by my coefficient. What are you going to get? 1. Negative. There goes 32. X to the first. Oh, I got another one. What's the exponent on the 10? X. This is to the first. Okay, so now I got to multiply it. 10 plus 10 x to the 0. Isn't that one? The next to the 0 one? Yep. Forget about the x. And that's it. Now somebody asked me earlier today, it's a really, really good question. What happened to the 4? Here's what happened. It actually has an x number with it. In other words, there's really an x squared, an x to the first, and there really is an x to the 0, but it's 1, isn't it? You know, we just simply don't see it. It's that invisible thing, kind of like the 1 right here, right? Oh, yeah. So what happens when you take 0 times 4? 0. It goes away, you don't worry about it. Is that clear? In other words, the velocity is not going to be affected by where it starts. Okay? All right. This is the slope at any given point. I want to know when is this equal to 0? At what point is this exactly equal to 0? How am I going to find it? When is this 0? 0 equals negative 32x plus 10. Solve that. Subtract 10 from both sides. I get negative 10 equals negative 32x. I divide by 32. And I get rid of my negatives, and I reduce, and I get 5 over 16x. 5 over 16, if you want it, 0.3, 1, 2, 5, whichever you prefer. So at a little less than half a second, it doesn't take long, and then it starts down again. I'm interested in how high it goes at this time. So here's my time. This is going to be, at my maximum height, it's going to be at 0.3125 seconds. And I want to find out, how high is it? How do you find it? Don't you have a function for that? Substitute this into your function. Substitute your number into your function. And you can do the fraction if you want to. I think you'll find that it's actually easier to do the fraction if you have to do it by hand, of course. If you got your calculator, you can substitute in decimal. It doesn't matter. They have to be exactly equal, so it works out nice.